Okay, girls, in this video, I'm going to go into a little bit more of detail and I'm going to explain types of data. So, types of data, remember that we said that there were two types of data. So, the first one we're going to talk about is categorical data. And categorical data can also be divided into nominal and ordinal. The second type of data is numerical. And numerical can also be divided into discrete and continuous. So I'm going to explain in detail what each one of these mean. So first, talking about categorical. So categorical data is non-numerical data, which means that it can use labels or categories. So for example, hair color or eye color or year level or types of pets, of movies that people like, or flavors of ice cream. Those are labels are categories that can be considered categorical data. Then categorical data, if it's nominal, is because the categories that are named for each of the possible responses. For example, if I talk about types of pets, so what categories can I have? Cat, dog, bird, fish, turtle, whatever, so on. So this, when we can have those categories, those ones are called nominal data. Ordinal means that those categories can be in some sort of order. Like for example, if we're talking about quality of work, I can say excellent, good, bad, satisfactory, non-satisfactory. So those categories mean that there is like an order between those orders. So it's not the same. Like if I had a nominal, like the example that we had before, and it was pets, I cannot say, okay, dogs comes before cats, because there is not an implicit order in those categories. But for example, if I'm going to talk excellent, good, and bad, then there is an implicit order in those categories. Wonderful. Now, numerical. So numerical is data that is recorded in numerical form. For example, number of family members. So how many family members is in your family? So that's like 5, 4, 3, 2, 1, whatever. So that's the data is recorded in a numerical form. Or what is the height of students? Okay, in year 9. So 1 meter, 150 centimeters, 160 centimeters, 175 centimeters, 185 centimeters. So those all is data that is recorded in numerical form. So if it's discrete, that means that the numerical values can only be expressed in integer form or whole numbers. So let's remember that integers are those positive and negative, but the important part here is that it's only whole numbers. So they cannot be fractions and they cannot be decimals, basically. Okay, so what examples do we have? So for example, number of stamps in a stamp collection. So that's, I either have 0 or 1 or 2 or 3 or 4. I cannot have 1.3 stamps, okay? Number of goals kicked each game by certain player. So same thing. You either have 0 or 1 or 2 or 3 or 4 or 5, but you can't have 1.7 goals, okay? So this type of data is what we call discrete data. Continuous data is numerical values that can be expressed as fractions or decimals as well as rounded integers. Like for example, height of the players in the basketball team. So height, it can be 170 centimeters, but it can also be 170 centimeters 0.1. Agree? Or change in temperature during the day. So the same thing, I can say, okay, it was 23 degrees today, or it was 23.6 degrees today. Okay, so these are some graphs. I put these examples for each one of these types of data so you can see others examples and also see how you can represent them. So this is basically what we had before in our previous presentation. So for example, if we're going to talk about type of degree, so high school, bachelor, MBAs, masters, law, PhD, then we have frequency, how many people have high school degree, how many people have bachelor's, how many people have MBA, how many people have masters, how many people have law, how many people PhD. Maybe this is in a certain group or whatever, but we can see the frequency there that in total there were 40 people that were interviewed. Then we also have a bar graph. I don't know why I cannot move this. I'm going to try to move. No, it doesn't allow me to move. I don't know why. I have lost my mouse, but that's okay. So then we have a bar graph, and in this bar graph we can see they're talking about hometown and how many people have rural hometowns, how many people live in the suburbs, how many people live in a small town, how many people live in the big city. So you can see that here they're talking about categorical nominal data, that we have categories that cannot be organized. Okay, in the next one we have a pie chart, and here is superhero battle winner. So they're talking about who is the winner in superheroes. So Batman, Captain America, Iron Man, Superman. So you can see again categories that doesn't have an implicit order. Okay, let's talk about categorical ordinal data. So this is data that has categories but has an implicit order. So for example, let's look at the first frequency table. It says frequency of ordinal data, example, frequency distribution of employees' perception on the behavior or their administrations. So it's certain employees that class like gave a survey and say the behavior of the administrator. So they say strongly favorable, favorable, slightly favorable, slightly unfavorable, unfavorable, is strongly unfavorable. So we can see that there is an order within those categories. And we can see that there was a total of 100 people surveyed in this frequency table. Then we have another bar graph, and this one is rating of service. And it says that they were rating a service, and we can see that the categories were very poor, poor, neutral, good, and very good. So again, there is a certain order to those categories. The last one is a pie chart that says self-assess health status for 100 patients. So these were 100 patients that self-assessed their health. And we can say again that there is an order for these categories: poor, fair, good, or excellent. Okay? Now let's look at numerical discrete data. So this one, for example, in the first frequency table, we have number of bathrooms. So again, here I cannot have 1.1 bathroom or 1.7 bathrooms. I have 1, 2, 3, or 4, 5 or more. That's the options. And then we have the frequency there. Then here in the one in the bottom, we have an histogram of numerical discrete. So this is Victoria's COVID-19 cases curve. So this one is graphing, and you have seen this lately a lot in the news, like how many cases, new cases are reported each day. And we can see here, again, we have 1 case, 2 cases, 3 cases, 100 cases, but we don't have 102.7 cases because we're talking about people here. So this is an histogram of numerical discrete data. The one on the top, you maybe have not seen this one, and we're going to learn how to do these graphs. Is called a whiskers box and whiskers plot. I think it's called box plots, I call it. And here what they're doing is the number of team wristbands sold daily. So how many wristbands were sold by 2 stores, a store A and a store B. Again, if I'm selling wristbands, I cannot sell 1.7 wristbands. It's either 1 or 2, agree? So this is an example of that sort. I'm not going to explain too much about this type of graphs now because we're going to talk about this one later when we learn how to do it. The last one that we have is numerical continuous. So in this one, in the first, we have a frequency table, and we have here height of certain people. And here, even though we don't have decimals, but we can say we could have a person that their height was 145 centimeters, 0.7, for example. So that's possible. So that's why it's numerical and continuous. So when you're doing a frequency table, you're grouping the table. Okay. Now Now on the right, we have a daily average temperature, and temperature again, you can have decimals if you're talking about temperature, you have a histogram there. And at the bottom, we have another box and plot, box and whiskers, I think it's called, plot. And this one is about bookstore prices. So books in a bookstore prices. So again, we can have a book that is $100.30. So this is continuous data as well. Wonderful. So I recommend, girls, that you go into Maths Online to these two lessons. Watch those videos because this is going to complement the information that I just gave you. And after you have done that, go to your Jack Plus and do the examples that are in your textbook, because that is going to help you with those questions that you have for homework. Thank you for watching, girls.